A small piece of space, they call it junk, had been causing a big headache for NASA scientists.
Houston is monitoring a piece of debris that could possibly pass in front of the International Space Station's orbit.
Talking about this 6-inch square piece, this old satellite.
The probability of it colliding with the International Space Station is within the red threshold. There is not enough time
to seek shelter.
Traveling at 17,000 miles an hour, if we were to hit the space station, it would really cause a very bad day.
Ignition sequence start. 6, 5, 4, 3, 2, 1, 0.
Реактор иммунот.
Я передаю трубочку первому. Готовы к взлому?
4, 5, 6.
The Eagle has landed.
JCAT,
That's one small step for man, one giant leap for mankind.
After half a century of space exploration, we're now suddenly faced with what's long been a staple of science fiction. An orbiting junkyard of cast-off space debris. The American Southwest is a breathtaking testament to the forces of nature that have shaped our world.
Okay, we're coming up on it now.
This is Meteor Crater near Winslow, Arizona. It is considered the world's best preserved meteorite impact site. Meet Donald Kessler, retired head of orbital debris at NASA. His guide, Eduardo Gonzalez, a 16-year veteran of Meteor Crater and a man who shares Kessler's passion for the wonders of the universe.
So Don, how was your ride up here?
Oh, it was wonderful. It was like landing on the moon.
But we're on Earth. Can you believe it?
At Meteor Crater, they always find common ground.
The result of a collision from the asteroid belt that happened 50,000 years ago.
For Don, this place brings some of the science of orbital debris to life in a big way.
Follow me and I'll show you.
Nearly 1 mile across, 2.5 miles around, and 550 feet deep, Meteor Crater is the astounding outcome of a nickel-iron meteorite hitting Earth with the energy of more than 20 million tons of TNT, creating all of this in just 10 seconds.
The fact that this meteorite came from outer space makes me awestruck.
We're just seeing a small slice of the process that really made the Earth what it is.
It's a sobering reminder of the incredible collisions that occur throughout the universe, from meteor impacts like this one to the collision of entire galaxies. Throughout time, space collisions have occurred as part of the natural process. Scientists believe that billions of years from now, our own Milky Way galaxy and its closest neighbor, the Andromeda Spiral Galaxy, could collide and merge to create a new giant elliptical galaxy, spewing stars along the way. Incredible. Collisions like this have forever played a major role in the creation and formation of our own solar system. It's this natural process that concerned Kessler over 30 years ago. Kessler's question was, if all of these collisions are occurring in nature, what's going to happen to all of the man-made objects we're putting into space? At the time, Kessler's thinking did not align with popular beliefs. Ever since humans ventured into space, we've embraced the big sky theory. The theory holds that space is so big, you could launch anything into orbit and it wouldn't collide with anything else. But it turns out that space is smaller than we thought. Low Earth orbit, or LEO as it's called, is home to the International Space Station, the Hubble telescope, and most of our satellites. In middle Earth orbit, we find GPS and weather satellites. Geosynchronous orbit, or GEO, the orbit farthest away from the Earth, is crowded with communication satellites. With so many objects careening through the same altitudes, it's not hard to imagine that some may eventually collide. Known as the Kessler syndrome, Kessler's prediction stated that random collisions between man-made objects would create smaller debris that would become increasingly hazardous to spacecraft. The resulting chain reaction would create exponentially expanding clouds of debris. Even if we don't launch anything else into space, this orbiting belt of debris could very well alter space exploration as we know it. Is it possible that we're now at the tipping point of this cascading, uncontrollable event? Alarmingly, in the 3 decades since Donald Kessler's prediction, the amount of debris in low Earth and geosynchronous orbit has grown at a rapidly expanding rate into a minefield of discarded trash.
In the past, most of the small particles came from the bigger objects falling apart. In the future, and we're reaching that threshold right now, the objects are going to come from random collisions, just like in the solar system.
Just like our once unspoiled ecosystems here on Earth, our orbits are becoming increasingly endangered. From space exploration to satellite communication, humans have developed a profound connection to space. What would happen if it were all to suddenly go away? Launched in 1993, Cosmos 2251 provides communications for Russian military and intelligence forces from low Earth orbit. Satellites like this are part of what's called a constellation, a grouping of satellites spread out in a set of orbital rings providing an uninterrupted stream of communications. With each rotation in as little as 90 minutes, these and thousands of other satellites orbit Earth 16 times per day. The gravitational pull from nearby Earth is so strong, every satellite has to travel at hypervelocity speeds, upwards of 17,000 miles per hour. The pull of gravity balanced against the satellite's velocity creates this curved orbital path. Satellites and their round-the-clock services are a fact of modern life. LEO is ideal for communications satellites like Iridium 33, which provides voice and data coverage for cellular telephones. With satellites like Cosmos and Iridium constantly crossing each other's paths, they often experience what satellite operators refer to as close approaches, two satellites passing within just a few short miles of one another. Amazingly, that can happen around 1,500 times a day. Space is indeed a busy place. Our planet's need for communication has transformed what was once called the final frontier into something far less romantic and far more congested. Just 50 years ago, the boundaries seemed limitless.
From a ground station nestled in the mountains at Andover, Maine, a signal is sent to a speeding satellite, an historic feat that could reshape man's future. That satellite, of course, is the Telstar. 170 pounds of messages and computer data, all can be handled by the orbiting device.
Ironically, this technological wonder died 1 year later, becoming what is known as a zombie satellite. Telstar began the revolution in communications that now features a fleet of satellites in the region we know as GEO. These satellites form a densely populated belt that circles the equator. They facilitate most of the world's television, military, and internet communications. Because its orbit mirrors Earth's rotation, a satellite will appear to hover over a point on the Earth's surface. The result? 24/7 continuous coverage from air to sea to land. Think about this. Here on Earth, when you download a music file, post a video, tweet, friend someone, or watch your favorite cable TV show, it's coming from GEO. Our busy lives on Earth have become deeply connected to space. Just like a coral reef or rainforest, GEO is a limited natural resource. There's only one spot in GEO for each satellite to maintain position. Satellites may drift due to gravitational pull from both the sun and the moon, slowly changing their orbits. Enter station keepers, the traffic cops of space. They send signals commanding satellites to adjust orbits by firing up the onboard thrusters, keeping them out of harm's way. But no amount of station keeping would have altered the course of what was to become the largest debris-generating event on record. In early 2007, an anti-satellite missile test took place in Leo. Its target, a dead weather satellite. In less than 24 hours, the debris encircled the Earth, hovering at the original impact altitude of over 500 miles. High enough so that the pieces won't come down, but low enough so that they have the potential to affect almost all other objects in low Earth orbit, including the International Space Station. Today, as the debris cloud keeps growing, so does our understanding of it. The majority of debris from this one event will remain a hazard in our skies for centuries to come. This visualization shows the formation of one of the first galaxies, massive stars filling the universe with light, beginning when it was 300 million years old and continuing up to its present age of 13.7 billion years. It's an awe-inspiring look at the lifespan of the universe, with galaxies forming and naturally colliding, ultimately spinning the massive thread-like structure of the cosmic web. At Lowell Observatory, Don Kessler is guided by Kim Herman, postdoctoral associate.
Arizona is known for its observatories, and fortunately very close to Meteor Crater is Lowell. All my life I've been interested in astronomy. I've visited several observatories that were designed for the purpose of looking at satellites, but never one with astronomy. Here, astronomers are well connected to the stars.
Bordered by a ponderosa pine forest 8,000 feet up, elevation and absolute isolation create a pristine sky for professional and amateur astronomers of all ages. The night sky here opens up infinite possibilities for the naked eye.
Here, the sky is so clear and so dark that we don't even need telescopes to see what's going on in the sky. Kim is using her smartphone to stargaze and know what she's looking at.
And over there, Saturn should be coming out.
When I think about Saturn's beautiful rings, I think of collisions in space and what Earth could look like millions of years from now.
Over time, collisions would create more debris and, in turn, even more collisions. Gradually, the debris would shrink in size and speeds would slow until finally the Earth would be surrounded by stable, Saturn-like rings.
When I look at the night sky, the first thing I notice is stars. The beauty of the universe is striking to me. The next thing I'll notice is meteors. If I see a meteor, I feel like I'm lucky because that also reminds me of these particles passing through space. Then I may notice something flickering and moving and realize that I'm looking at a satellite orbiting the Earth. Those satellites are there because we put them there. I may see another one traveling in the opposite direction. It could collide with the first one. Their paths do cross. An astronaut was asked this question, when you're in orbit and see these things in space, does that worry you? His answer was, I worry more about what I don't see.
Our belief that what goes up must come down isn't always true. It's estimated that LEO contains 6,000 tons of space junk, and GEO is home to 400 dead satellites parked into a higher graveyard orbit where they will remain for hundreds of years. That's a whole lot of junk. So what exactly is out there? Over the last 50 years, we've launched several thousand objects into space. Yet there are only around 1,000 spacecraft that are operational at this time. What may surprise many people is that once an object stops functioning, we leave it in orbit. Every single one of these non-operational spacecrafts is a potential source of debris. In fact, most spacecrafts that are launched into orbit actually leave a trail of debris in the process. Upper stage rocket bodies weighing several tons make up a good portion of the junk in space. As do mission-related objects like cast-off bolts or O-rings. The rest are miscellaneous fragments, exploded rockets, leftover fuel, and the list goes on. But even with this incredible amount of debris, few people were taking the notion of space junk seriously until the morning, February the 10th, 2009. Earlier that day, a report was issued predicting that Iridium-33 would encounter a close approach of just 1,900 feet with another spacecraft. It's Cosmos 2251, traveling at the same speed as Iridium. Amazingly, this collision alert wasn't even among the top predicted for any of the Iridium satellites for the coming week. But at 4:56 p.m., the time predicted for the close approach, Iridium-33 went silent. Two satellites that had simultaneously circled the planet for 12 years had collided. Cosmos, as it turned out, was a dead satellite, ceasing to function in 1995, just 2 years after it was launched. Now, more than 100,000 pieces from this collision cloud low Earth orbit.
The Iridium-Cosmos collision was very much a game changer. There were those who thought of space in terms of a big sky theory, that it was limitless and we didn't need to worry about ever crowding it. It became very obvious that that wasn't true, and people began to consider, what do we need to do to keep this from happening again?
Far from space, deep in the desert near White Sands, New Mexico, sits the remote hypervelocity test laboratory, where engineers are providing solutions required to advance space travel in the face of these gathering obstacles. Scientists analyze what we can only imagine: hypervelocity impacts, collisions between objects traveling at speeds of up to 15,000 miles per hour. These scientific visualizations show a fragment no bigger than a BB, blasting through an aluminum plate, typically used to protect spacecraft. Even the smallest of impacts scatter debris, delivering widespread damage. Whether it's a circuit board, a wayward bolt, or even the tiniest chip of paint, orbital debris traveling at these speeds poses a very real threat. Because of this, the International Space Station features extra shielding, as shown in red, over the areas most likely to be hit. To further protect the ISS, its orbit is monitored within what is referred to as a pizza box, creating a safe zone on all sides to help keep it out of harm's way. That's the job of the US Space Surveillance Network, where they detect and catalog man-made objects. Utilizing a vast array of radars and sensors, we're able to track thousands of pieces of space junk larger than a softball. Some of them, like rocket boosters, are the size of a school bus. But what's far more troubling is all the debris that can't be tracked. Debris the size of marbles, among them waste from rocket propellant and fragments from collisions, is capable of inflicting lethal damage. Millions of particles the size of dots are far beyond detection. But the craters they produce on spacecraft are well documented. Most importantly, the network charts the orbital paths of the catalog debris and issues collision alerts to station keepers. So where do we go from here? Forces of nature and natural collisions will continue to shape our universe. But man-made collisions? Perhaps those we can do something about.
The good news is that people have begun to come up with new ideas to bring back the pristine environment that we would like space to be.
Scientists and engineers are developing breakthrough innovations to help us begin cleaning up space someday soon. The question is, how do we catch up to and capture debris tumbling through low Earth orbit at thousands of miles an hour? And then, how do we slow it down so that it falls out of orbit and burns up in the atmosphere? One fascinating concept involves the use of an electrodynamic tether, which would deorbit a spacecraft by generating drag through interactions between currents in the tether and the Earth's magnetic field. This increased drag would lower the spacecraft out of orbit until it re-enters the atmosphere and burns up. we may also be able to capture debris with a net. Japan's space agency has been working with a fishing net manufacturer to look at creating a space fishing net which, like the tether, could be powered using the Earth's magnetosphere. Imagine that. A centuries-old fishing tool might just become a brand new tool for cleaning up space. Lasers could one day sweep space, striking smaller objects, slowing them down, and causing them to tumble into the atmosphere. Solar sails could someday be part of the satellites we launch, helping them to deorbit once their work in space is done. Spacefaring nations are now working to develop sustainable methods to explore space and new technology to reclaim what has been left in orbit. As we continue to launch our dreams into space, what if one day objects in space were located and captured by a garbage vehicle? The vehicle could then dock at a recycling facility, a place where space debris could be stored and recycled to create new parts. Imagine aluminum and fuel from centuries-old upper-stage rockets recovered and poured into an industrial outer space post.
Industrializing space is never an issue of science fiction. It's more of a question of, do we want to do it, and when do we have the infrastructure established so that we can do it? It's what we will do in the future as we move out into space.
Space-based recycling could someday become a reality, launching a new, greener era of space exploration. For as long as humans have walked the planet, we've looked at the heavens to help us define our role in the universe. The celestial bodies in our skies and the constellations they form have forever shaped our notions of time and place. Today, constellations of our own making fill the night skies. As we continue to push skyward, relying on what the universe has taught us, where would we be if we couldn't consult the stars?
Growing up, it was my fantasy that I would get to see humanity spread off of the Earth and throughout the solar system. So, do I think this snowballing event will actually happen? I can't imagine, after dreaming and working towards spaceflight, and after 50 years of having achieved it, that we would ever cut ourselves off from space. That goes against everything that humanity's ever strived for. My legacy will probably always include being known as the father of space junk. What I hope that means is that we continue to maintain access to space and learn more about life and the environment.